Hello, this is Nick Bertozzi again, just wrapping up our discussion on linkages. And the topic that we'd like to talk about right now is transmission angle. So transmission angle is the angle that you have between the coupler and the output link that's being driven by the coupler. The transmission angle gives you a measure of quality of the force that's being applied through the coupler. We would like to have a 90-degree angle between the coupler and the output link. The force that the coupler is applying can be broken into tangential and radial components. And the radial component doesn't do anything to rotate the output link. It's only the tangential component that does that. So at 90 degrees, 100% of that force would contribute to rotation of the output link. So in general, most designers like to keep that angle larger than 40 degrees one way or the other. In some cases, you can't do that, but especially in cases where you have enough rotational inertia, it may not be a problem. Of course, the easiest example to think of is a single-cylinder engine, where obviously at certain points the coupler in that case is driving the crank on the crankshaft, and there are certain orientations where obviously the transmission angle is less than 40 degrees. And of course that's one of the reasons why you want to have multi-cylinder engines offset, so that you're never in a situation where all of the forces being applied by the coupler links are at small angles and not contributing much torque. And just to review something we've covered before, toggle positions. Toggle positions in a linkage happen when two of the links are collinear, they're lined up, and at that case, in this case, they could go either way. So we looked at the difference between open configuration and a cross configuration in a 4-bar previously. So sometimes that toggle position is undesirable, so you might have some kind of physical stop to make sure the linkage doesn't go into a configuration that you don't want it to. But sometimes this toggle position is very useful, for instance in the case of a folding table. So if you open up the table and then you can just have some kind of slip or lever or something, it doesn't require a lot of force, that then holds that linkage in that toggle position, you can't backdrive it. So with just a very simple clip, you have a very stable locked position because you're holding it in that toggle position. Another common example is if you think about vice grips. So let's think about vice grips, and let's assume that we're not moving the screw that adjusts the opening of the drawers. So they're already in the right adjustment. So we're not moving the screw. We're just looking at it as a 4-bar. If you look at the vice grips, you can count the links, and it's a 4-bar linkage. And what happens is you tighten it up on something, and as you squeeze that handle to try and move past the toggle point, you move slightly past the toggle point, and some of the links are being compressed, some are being stretched, so it's actually changing shape a little bit, and it locks into place so that it can't, it locks whatever you're holding. You can't back it out unless you apply force to stretch it back out and pull it past that toggle point the other way. So that's a 4-bar. But now let's think about if we look at the vice grips with that adjustment screw, right, and we think about the end of the adjustment screw and think of that's in this captured here, so it's really like a pin joint. And then you have the adjustment screw, which is a screw joint. That's a full joint. It has a single degree of freedom, right? I mean, as you actuate that screw, it can only go in one spot. Let's just review the mobility equation now. Mobility equation says that we have, as shown here, 3 times the quantity L minus 1, minus 2J1 minus J2. So what happens when we add in that screw? Well, we add a link, so that increases that sum by 3. And then we're subtracting off a full joint, so that decreases it by 2. So the mobility just went from 1 to 2. And you think about it, that's really what you have, right? You can rotate the linkage, the vice grip, and by also actuating the screw, you have another degree of freedom. So it's really now a 5-bar with 2 degrees of freedom. So you have to both actuate the links, apply a force on the lever to move it, or move the adjustment screw to get a different kind of motion. So I think that kind of wraps up our discussion on linkages, and hope that this is helpful.